Okay, so we can start now. So have you completed both of the questions? Can you all hear me? Okay, so both of the questions now we'll discuss. So I'll be telling the marks also you can put, okay? Okay, the first question is the organic essay. Let's start with the organic. The reaction scheme to synthesize compound 1 using 2-propanol as the only organic starting material is given below. So we have to make compound 1. So you have to make C from that downward pathway, you have to make C, and that C is added to the other pathway, and then finally you are getting that. Okay, and they have given the list of chemicals also how you have to approach. Okay, now here, okay, let's start with the first one. Now they have given 2-propanol. And this is 2-propanol. Okay, so one pathway go like this, another one is going like this. Now in the final compound, you can see 1, 2, 3, 4, 5, 6, 7 carbons are there. But our starting compound is having only 3 carbons. Okay, so that means the compound C which you are adding should have 4 carbons. Then 4 and 3 will give you 7 carbons. Okay. Okay, let's start like this. So first I'm going to start this side with PBr3. Okay. Then what happens? This OH is being replaced by Br. Now I'm going to add KCN for this. So when I add KCN for this, what happens is this Br will be replaced by Cn. And you can see that one carbon number is increasing in this compound. Okay. So that way also we can do this. So Cn. Now I have 4 carbons. Okay. Okay. So next what I am going to do is I am going to oxidize this. Just if you put dilute H plus, okay, what happens is this Cn will get oxidized into carboxylic acid. Now I am going to reduce this for an alcohol. Okay. So you know that if you want to reduce carboxylic acid to alcohol, you have to put lithium aluminium hydride water. Okay, that is the only reducing agent for carboxylic acid. Then this carboxylic acid will get converted into an alcoholic group, that is CH2OH. Okay, C double bond O is being diminished. Now here you can see this is secondary alcohol. Sorry, a primary alcohol. Okay. Now you can oxidize this primary alcohol by using PCC. Then this alcohol is being oxidized to an aldehyde. All right. Now ultimately I want the final compound. Now here only C comes. Okay, when C reacts, I'm getting this compound CH3, CH, CH3. Here CH, double bond N, CH2, CH2, CH3. It's a propyl group here, okay, with N. That means something with N you have to add as C, okay. Now here it's aldehyde now. So we can add a amine here. So the amine will nucleophilically add to the aldehyde, okay. It can undergo nucleophilic addition reaction. So now here we have to convert this for an amine group, okay. First, we'll get rid of this OH. Okay, I'm putting a dehydrating agent. I'm putting Al2O3 and heating this. Then OH will get removed. A water molecule is being removed and alkene is forming. Then now I am adding Br for this. Br2. Not Br2, sorry, HBr. 1 bromine. CH3, CH, Br, and CH3, CH2. Now for this Br, I am adding ammonia. Now alkyl halides can react with ammonia, so that's why I put a Br, okay? Then CH3, CH2, CH2, NH2. Br will get removed with the one hydrogen of the ammonia and remaining NH2 will join here. So this is C. Okay, so when you add this for the aldehyde nucleophilically, it can add. Okay, nucleophilic addition reaction can take place and our desired compound can come. Is that clear? Any doubts? So I think we have used all the reagents they have given, but not magnesium dry either. For that dilute acid part, you can put H3O plus because that is the one they have given in the list. Okay. Is everyone clear? Shall I move to the next question? Do you need time to copy this or for any correction? Okay, then shall I move to the next question? Okay, I'll give you around 2 to 3 minutes. Work out on this. Okay, now let's go to the next part of the question. Okay, next question. Show the following conversions that can be carried out in not more than 4 steps. So you can't exceed more than 4 steps. Now here reagents or anything are not given, so you only have to work out. So you can see the first initial compound is having only 2 carbons. But in the other compound, you can see that the product is having 4 carbons. Then you should work out such that you double the carbon number, right? Okay, let's see how we can do that. So now here you can see you have diene. So that means the previous compound, you have removed something. Then only you can make it a double bond, right? So we can keep it as a dialcohol also, right? We can keep it as alcohol. So when you remove if you put a dehydrating agent, water molecules will be removed, no? The OH groups will get removed and a diene can come. Or else it can be alkyl halides on both the side as well. But I guess we can work this out with alcohol. Let's come from behind. CH3COH H. So if you are removing an alcohol, OH has to be here. Okay, this OH and this hydrogen will get removed this side. And then you need another OH also this side. Then OH and H will get removed. So for that you have to put a dehydrating agent and heat. Now, next step what you should do is you have to now you should work out how you are getting this alcohol, right? Now we'll come from this side. Now this is a alkyne. So I guess we can oxidize this. I mean with Hg2 plus dilute H plus and H2SO4. And then now this, you know that this will go for a aldehyde because the alkyne with 2 carbon only give aldehyde. Okay, all the other alkynes will go for ketone, but this goes for aldehyde. Now if you put dilute NOH, you know that one of the aldehyde will turn into a nucleophile and that nucleophile will get added to this aldehyde. Okay, and then the carbon number doubles in this reaction. Is the aldol condensation reaction. Okay, CH3COH and H. And then you get this aldehyde part, CHO. Now what you do is, now here you can see this one OH part is already there. Now what you can do is this aldehyde group. Okay, you can reduce this to an alcohol. So you can use lithium aluminium hydride first step and then water. And you will get this OH also. And then if you heat it with a dehydrating agent, you will get the product. Is this clear? So I'll give you a minute. Copy down this if it is wrong and work out how the pathway. Okay, now sometimes you can come with the reactant. Many times you can easily work out from the behind. That's easy. Okay, come with the product to the reactor. Is this okay? Shall I go to the next one? You have to tell me, I'm waiting. Anything to clarify? I'll go to the next one. So now here you can see that you have an aniline, no? A benzene with a NH2 group. Now this you have to convert to a compound like this, where you have a carboxylic acid and 3 chlorines. So how can you work this out? Now first what you have to do is, first you have to add this chlorine. Now this NH2 is also like phenol. It is very much activating the benzene ring. Therefore if you just put Cl2 aqueous, 3 chlorines will get electrophilically substituted to the benzene ring because this making the benzene ring active like phenol. Then now convert this NH2 group for diazonium salt. How do you do that? You have to put NaNO2 with Cl 0 to 5 degrees. Then that NH2 is being converted to diazonium group. What's diazonium? N2 plus Cl minus. Now this diazonium salt, there are few reactions. You can put CuCN. I'm putting CuCN so that this diazonium salt is getting replaced by the Cn group. And that Cn group I can oxidize for carboxylic acid, okay? Cn. Now Cn I can oxidize for carboxylic by just putting water, dilute acid. Not water, acidulated water, okay? Is this clear? Any doubts until now? Do you need some time to copy this? Otherwise, I'll go to the next question. Do you need? Okay, I'll wait for a 2 to 3 minutes. Okay. When you're done copying, drop a message. Okay, next question. So next one is a explanation question. You have to explain why amines are greater in basicity than the alcohols. Now we know that alcohols are more acidic, amines are more basic. Now you have to tell why the basicity of amines is greater when compared to the basicity of alcohols. Okay. Now basicity means what? Gaining an H plus. So H plus gaining ability of the amine is greater than alcohol. Now you have to explain that why. So for that you have to directly, now in the marking scheme also you will observe that they have directly taken the points from the resource. In the resources they have explained this very clearly. Okay. So whatever the explanations in the resource are very important because they can directly come to the essay question, and the scheme is also directly made from the resource book. So I'll go to the scheme for that so that you can see how they have given marks for the points. Okay, look at this. Basicity of amines is greater when compared to the basicity of alcohol. When such questions come, you have to always write a reaction. Okay. Like you don't need to put the exact molecule or anything. You just put a R group and the particular group they are referring to. So here alcohol and amines, no, so they have used ROH and RNH2. So ROH with water, you can see that now here we have to show basicity. Then you have to write the reaction as accepting an H plus. So they all have accepted H plus and released OH minus. So if something is releasing OH minus in solution, that's basic. Now, so releasing OH minus reaction of both alcohol and amine is shown. Now they're telling that amine's basicity is greater. That means this reaction's equilibrium is shifted more forward. That's why it is more basic. But the equilibrium of the alcohol towards the forward is less compared to the amines one. So that's why amine is more basic than that. The reason for that is the stability of the ion. Now here, alcohol gains an H plus and forms the alkoxonium ion. Okay, alkyl oxonium ion. Then here it forms the alkyl ammonium ion. The stability of alkyl ammonium ion relative to amine is greater than the stability of alkyl oxonium ion relative to alcohol. Now this alkyl ammonium ion stability is greater than relative to amine is greater. That's why equilibrium is this side. If something is stable to the product side, it favor forward, right? Not backward. But the alkyl oxonium ion stability relative to uh, the alcohol one is less. Okay. So that's the first point you have to tell. The stability of the alkyl oxonium ion relative to alcohol. Okay. You can't just say alkyl oxonium ion is less than that of the alkyl ammonium ion relative to amine. Therefore, the above reaction proceeds more readily in the amines than in alcohol. Then another reason is the electronegativity. Electronegativity of nitrogen is less than oxygen. If electronegativity is less, you can easily donate electrodes. Now, basic ones, they donate electrodes, right? They're donating electrons. Now, nitrogen electronegativity less means easily you can donate. But oxygen has greater electronegativity. Electrons are more tightly bonded, difficult to donate. Electronegativity of nitrogen less than oxygen, their tendency to donate is greater in nitrogen, okay, because electronegativity is less. Therefore, they can act as Lewis bases. Amines basicity greater than the alcohol. It is more stable to have positive charge on nitrogen rather than oxygen. You know that positive charge on oxygen is usually unstable, right? But nitrogen having positive charge is stable. Therefore, you finally put the conclusion message, basic character of amine greater than alcohol. So this exact description you can find in the resource book also. Okay. Okay, I'll give you around 2 minutes. Quickly work out on the answer and see how they have break down the marks. Okay, 14 marks for this. Okay. Yeah, it's better to write water than H plus. Okay, because we are dissolving them in water. No? Better next. You better stick to water than H plus. Yeah, wherever it is, if you have these exact sentences now, first, especially these first two sentences, the stability part, that has to be exactly correct. That means you have to tell alkyl oxonium relative to alcohol. Likewise, you just send me the answer. I'll go through it. And if there's any error, I'll let you know. Okay. Then shall I move to the next question? Next one. Consider the reaction given below. So they have given a reaction CH3CCl, CH3, is reacting with NaOCH3, forming P plus Q. Write the structures of P and Q of the above products. Here P is an unsaturated compound. Okay, P is an unsaturated compound. Now what are the things can happen? Now one possible product is this Na plus can take the Cl minus out and this OCH3 can get added here, substituted here. Okay, alkyl halide substitution reaction, or else it can favor the elimination. Uh, it can either favor. Now, sound might be a bit different for you, but we have worked this out with either alcoholic KOH or anhydrous KOH. Okay, so if you have alcoholic KOH, what happens? Elimination will be favored for the alkyl halide. But if you have anhydrous, what happens? Substitution will be favored. That means this OH group will get substituted. But here instead of OH, what you have is OCH3. That's the only difference. Okay. So they say P is an unsaturated compound. Okay. So P they say unsaturated compound. So if you want to have an unsaturated compound, uh, then what should you should have a double bond, right? Therefore, P is the one where the elimination is favored. So Cl and one of the H will get removed. CH3, CH3, double bond CH. Other one, what happens is the substitution reaction. That means Cl will get substituted with OCH3. Okay. So that's P and Q, and they're going to write the mechanism of the reaction corresponding to the formation of P. That means elimination reaction mechanism, no? Okay. So you have CH3C, Cl, CH3, CH3. Now first is now NaOCH3 means it is Na plus and O minus CH3. Okay, this O minus, like you have OH minus, okay, this is O minus CH3. So O minus CH3 groups come. What happens is one of this methyl group. Do we have like the elimination reaction mechanism in the resource book? I of course can't remember. I think we didn't have it. This mechanism, I don't think we have it, but we can work out with the electron transformation. Now here what happens is, Now oxygen has lone electrons, right? It will donate to one of these hydrogens. So it can be any alkyl group, okay? This one, or this. Once it is donated to the hydrogen, this bond will cleave. This bond will give for this bond because hydrogen is being removed, okay? Then once we give for this bond is going to cleave. Then we get our unsaturated compound. Then you will have a Cl minus also, which was removed. And you will have a CH3OH as well. Because this OCH3 gets a hydrogen. Is that clear? With that, the organic assay is done. Any doubt you have? Shall we go to the inorganic assay? You mean the mechanism? Okay. Okay, so see how the electrons are being passed. So you have a CH3 group, C, Cl, one CH3 group, and other CH group I'll just spread out and write because it's needed for the mechanism. Now in the elimination, you know that one hydrogen and Cl has to be removed. No, HCl no removed. Now here what happens is we have a OCH3 minus group which is going to now attack this molecule. OCH3 minus. It's very similar to OH minus. Okay. Now this oxygen have electron. Therefore, this electron is being donated to this hydrogen and this OCH minus is taking up this hydrogen. Once this hydrogen is taken up, we can give these electrons for this carbon. Okay. So then here a double bond will be created. Okay. Then this chlorine is getting cleaved. This electron is donated to this chlorine. Therefore, it will become Cl minus because it's getting extra electrons. It becomes Cl minus. This O minus CH3 is getting the hydrogen. It becomes CH3OH then. And then you form this unsaturated compound. Now, is that clear? HCl is only, it's hydrogen and chlorine only. In the elimination, we are removing. Okay. Now then we can go to the inorganic one. Okay, were you all able to identify the things? Anything you identified? So first you have to find the three cations and the two anions. Okay, send me what are the cations and anions you found out. It's okay if it's wrong or anything, it's fine. Just send. Okay, one have answered, other. Can you tell me what are the cations and anions you found? Yes, can you tell me what are the cations and anions you found? You identified with the negative question. Okay, we'll continue. So look at the question. An aqueous solution X contained three cations and two anions. Following experiments were carried out to identify the above cations and anions. X was acidified. Now X is a solution. They are adding dilute HCl and H2S gas was passed a clear solution. That means no any sulfides precipitated in the acidic medium. The above solution was boiled to expel H2S gas completely. And after adding a few drops of conc HNO3 and they adding ammonium chloride, ammonium hydroxide, then you get a white precipitate. You know, 3 hydroxide will get precipitated, no? Aluminium hydroxide, chromium hydroxide. Now, this is a cation analysis, okay? Chromium hydroxide and ferric hydroxide. Out of that, the white one is aluminium, no? So, obviously, P1 has to be what? This one, aluminium hydroxide and the cation. That means we have aluminium in the solution. Okay. P1 is aluminium hydroxide, okay? In the Roman number 2, they ask the precipitates also. So we'll just write that and also go. So we found out cation aluminium 3 plus. Then P1 was filtered and removed and H2S gas. Now you are passing H2S gas in the basic medium. You are getting a black precipitate, P2. There are two black precipitates, right? Cobalt and nickel. So we can't confirm. We'll keep that, okay, for a while. Okay, they are doing a test for P2 precipitate. Look at that, the seventh one. The precipitate P2 was dissolved in aqua regia and ammonia solution was added dropwise, green colored precipitate, and then excess ammonia is giving a dark blue colored solution. That means hydroxide is green of that cation. Amine complex is blue. So that's nickel, no, not cobalt. So we confirm that P2 is nickel sulfide and another cation present is nickel 2 plus. To the remaining solution, 8-hydroxyquinoline was added. Now that's a new pathway in the cation analysis. Yellow-green precipitate, they have got. That means you have magnesium in the solution. No doubt it's magnesium. That's it, no? Those are the three cations. Now for the P1 also, they are doing another confirmation test. See number 6. NaOH is added excessively to P1. Then you get a clear solution. So that's forming the hydroxy complex. That's why clear solution. Dissolving. So that's definitely aluminium. Now they are adding barium nitride and you get a white precipitate. Then you put, for a barium precipitate, you put dilute acid and that's not dissolving. So the only white precipitate of barium, which is not dissolving in dilute acid, is barium sulfate. That means you have sulfate in the solution, SO4 2 minus. The precipitate P4 was filtered and now dilute HCl is added. The white precipitate does not dissolve, so that is sulfate. To a portion of the filtrate obtained in 8. Lead nitrate was added. White precipitate. Again, when you heat and cool it, needle-like precipitates are coming inside. To another portion of the filtrate, AgNO3 was added. Pale yellow precipitate is obtained. That means the silver halide is pale yellow. The precipitate P6 was separated by filtering, concentrated ammonia was added to it. It dissolves in a clear solution. So that silver halide is dissolving in concentrated ammonia. Now it cannot be chlorine, it has to be bromine. Because chlorine means it can't be a pale yellow precipitate. No, it has to be bromine. It's not iodine because iodine does not dissolve in conc ammonia. But this is dissolving in conc ammonia, so it's definitely Br minus. So P1 is that. P3 is the nickel hydroxide. P4 is barium sulfate. P5 is then lead bromide. Actually, lead chloride only needle-like precipitate, no? Lead bromide and lead iodide, they give crystal precipitate. We don't say needle-like precipitate, lead bromide. But it has to be bromide because with the silver nitrate, it's bromine matching. So they have to tell crystal precipitate, okay? Sometimes you might get confused with the needle-like thing, but you can further confirm it, I guess, with the silver. So no problem. P6 is then silver bromide. S1. S1 is the solutions, no? So those solutions are with amine complexes. S1 is dark blue, the nickel amine complex. So you have 6 ammonia, then complex cation 2 plus. S2. Where is S2? Yellow colored solution is R. Now you can see 7th Roman number 3. They are adding conc HCl. Then they form the chloro complex. Chloro complex is yellow. So too many confirmations for nickel. So that is nickel chloro complex. No, because we don't have chlorine. Because if you have chlorine and bromine both, then you can't get observation. That's what I said. They can't say needle-like precipitate. They have to tell crystal precipitate. Okay? That has to be changed. Sometimes you might think it's lead chloride, but with the silver nitrate test, we knew it's bromine. We don't have chlorine in the solution. They have to tell crystal precipitate. Okay, then it's correct. Is that clear with the identification? Okay. So next they are asking, what is the reason for the boiling the solution in experiment 2 and H2S gas is completely removed? Now you know that before that H2S was added in the base acidic medium and then you will get lot of a set of precipitates, right? After what you do is you boil the solution so that all the H2S gases are removed and then only you are adding ammonium hydroxide, ammonium chloride in the cation analysis chart. Now they are asking why you are removing this H2S. Now, if you don't remove the H2S, okay, now if now what happens is, now here H2S is there now. If you don't remove the H2S and if you add NH4AH, what happens? That means now the medium is being basic. Okay, the medium is being basic and the sulfides which are precipitating in the basic medium will start to precipitate here. Now, what you need here is the hydroxides, right? You need the aluminium, ferric, chromium, those hydroxides to get precipitated. If you have H2S, the sulfides, after this now the sulfides which are getting precipitated in the basic medium like nickel, cobalt, those can get precipitated if you have H2S. Then you can't observe, you can't identify the available cations in the solution. Okay, so that is why you remove H2S and only add this NH4OH, NH4Cl. Then these hydroxide precipitates. Afterwards, again, now the medium is anyway basic. Now you add H2S again, so that the sulfides in the basic medium are precipitated. So if you don't remove H2S in this step, it's going to be an error. You can't find these out. If they are in the solution also, sometimes you won't be able to see them. Now imagine if a nickel sulfide get precipitated, it's black color. Although aluminium precipitate, you won't observe it because it's white. So that's why we remove H2S, okay? If H2S is not removed, the group 4 cation will precipitate upon the addition of NH4OH, NH4Cl. So if H2S is removed initially, if it is not removed, nickel 2 plus can get precipitated. So we have to remove it, okay? Is that clear until that? After that, we have the redox question. Okay, any doubts until this? Okay, now I'm stopping the class. We are continuing this class in the weekend. Okay, weekend I'm taking another class, either Saturday or Sunday morning. Okay, I'll inform you that. I'll continue the redux question. And we are going to do some kinetics essay questions. Okay, this weekend. So we'll continue the class at that time. Now, if you have any doubt, you can. We remove H2S to avoid the group 4 hydroxide precipitation. No, group 4 sulfide precipitation. No? 1, 2, 3, 4. Yeah, group 4 is the sulfides that precipitate in the basic medium. So we are removing that to prevent that. Group 4 sulfide precipitation, not hydroxide. Hydroxides, they precipitate in the group 3, aluminium, ferric, and chromium. Okay, is it clear? Okay. So I'm pausing the class from here and we will continue in the weekend. So we will continue the redox discussion. And then I'm doing kinetics essay questions like I'm doing during the class. You will have to work out during that time and then we discuss essay type. Okay, so make sure you revise the kinetics theory. Okay. So I'll wind up for today then. Assalamu alaikum.